Okay. Hello, everyone. I think that everyone should be able to hear me and see me now. Right. Yeah, the go for smashing the keyboard is intentional. Okay, good. Well, welcome everyone, and thanks for joining today for this technical test. Today, my plan is to have some questions live and some questions that I recorded from Twitter questions that were asked. Since I'm very professional, I recorded them in a very technological piece of paper because I don't trust technology, not at all. So, first a disclaimer. Everything that I'm gonna say today here is not an official Google statement. So I cannot discuss anything that we do in the Google security team or in the Go security team. Everything that I say here comes from me and me only. And once we got that out of the way, I wanted to introduce you a bit to what I plan to do with this series. So I am a developer. I consider myself mostly a developer, even though I am a security engineer as a job. Hello, welcome Miki, welcome Calx, and welcome Matteo. As I was saying, I consider myself a developer, and I'm sad that there is some sort of division between security and development, because software engineers tend to not have time nor have the energy to invest into learning security practices, and on the other hello everyone. And on the other hand, security engineers tend to be in a separate team, separate company sometimes from the software engineers. So I've noticed that there is this big gap, and I'm trying to fill it. So security is always seen as a scary thing on the software engineering side, or something that someone else should take care of, or that people can take care of later. And on the security engineering side, software engineers are seen as the people that get things wrong. And most of the time, I've seen people just dismissing vulnerabilities as a source of ignorance or something to laugh about, without realizing that it's the security engineer team responsibility to help developers figure out how to fix stuff and not even make the mistake in the first place. So this is my plan for this series, and this is my idea for what I'm gonna do. That said, tonight is probably going to be just Q&A and maybe a little bit of code depending on the question, because I just wanted to first not overlap with GopherCon, because there is a big conference going on right now in the US, so I didn't want to have to compete with an actually professional conference. And second, because I've seen a lot of questions they wanted to address before I start with my program. That said, if any one of you has an argument that would like to see treated and expanded in this series, just please ask, either on Twitter or YouTube or via email. I'm going to add all my addresses in the description box, and we can maybe decide the plan for this series together. So, going with the first question. We have, I think, Luigi and Fabio asked about multi-factor authentication and two-factor authentication recovery, which is, well, thanks for the question. It's not an easy one. Multi-factor authentication is complicated. It's something that was added on top of passwords, and I think that was already a mistake and that created a lot of complications, and people are not used to work with it, so it just created a lot of confusion. When we talk about multi-factor authentication, what I mean is usually websites authenticate you with something you know, which is usually your password. And then they can also authenticate you with something extra, which is something you have or something you are. The example of something you have is, for example, stuff like this. So a security token that you have to plug into your computer and touch to authenticate, and something that you are could be, for example, a fingerprint. These kind of concepts combined are what makes up for multi-factor authentications. But while passwords are easy to kind of back up and store, for example, there are password managers, or there are tools that can help you generate a password based on the URL, or you can have your own mental schema to remember your passwords, which I strongly suggest against. Second factor authentication is hard to recover, because if you lose a token, or if you lose your phone, sometimes the phone is the thing you have. It's hard to prove that you have something else that serves as a backup. For example, let's say that you're supposed to remember where you put your token or where you put your phone, and your phone gets stolen. It's very likely that the other backup mechanism, so for example, I don't know, a one-time key that was given to you, was also backed up on your phone or in a service that you can access from your phone. So the second factor of authentication needs to be strong and needs to be hard to lose. And when you lose it, there should be a way to recover it. And I think this is the hardest part, because if you make the recovery path too easy, the attackers will go there, will go for the recovery path. I remember that when I was working for Microsoft, one of the biggest issues that we had was that in some paths, in some services, it was much easier to go for the lost password and guess the secret questions answers, rather than trying to guess the password. And this is not true just for passwords, but is also true for any other factor of authentication. So this is actually a complicated question. I'm not sure that there is an answer yet. One thing that I think is important to consider here is, I think the second factor of authentication that we use nowadays is much more secure than the first, because while users get to pick their passwords, which is extremely dangerous, users don't get to pick the cryptography that runs on their YubiKeys or on their Google keys, or I guess it's called Titan now, or on their phone. So I think that it's much harder nowadays to break a single factor authentication that is based on your phone than there is to just guess your password. And this is actually something that is very sad. I think passwords have seen their times, and we should probably find alternatives before problems start arising. I see there are people in the chat. Resources or tools for static source code analysis for Go programs. Wow. So I'm not an expert in this field, because inside Google we have our own custom analysis frameworks and pipelines. What I know is that there is a tool called Go Meta Linter that aggregates several linters, and there is a static check, which is a very good tool that you can plug in Meta Linter that has a lot of checks. Moreover, I think Damian Grisky, I probably just butchered his name, is investing a lot of time in writing new checkers every day to try and collect them together and build some sort of a suite that allows you to find maybe a lot of false positive, but almost like ideally zero false negatives. One thing that I think people should be careful about when they write static analysis tools, which in Go is very easy, is about the rate of false positives. For example, with the analysis framework that there is built in the standard library in Go, you can easily build a pass for example, Go vet. You can just write a bit of code, analyzes and passes over your Go, and gives you some hints or some even refactorings or some suggestions on how to rewrite your code if there is something wrong. Michael Matlub did an amazing talk about this, and I suggest everyone to take a look. But the problem is, if you're doing something that is secure, like there is 100% secure is wrong, the checks for something wrong is good. For example, the example he gives in his talk is about the CMP package that takes two empty interfaces, but it requires you to pass two items of the same type. And it's very easy to write a checker that checks that both variables are the same type. And in that case, it's fine. You can write an analyzer like that. It's very good. But if you write something that is like guesswork, for example, you see that an error variable has been masked in the current function, which is a common source of mistakes, you should be aware that the more warnings you issue to the user, the less the user is going to be willing to take a look at them. This was, for example, the problem with C compilers. Every time I wrote a C program in my life or took a C program and tried to compile it, I got like, I don't know, several hundred lines of warnings, and nobody has time to read those. So try to not make the Go developer experience feel like the C developer experience, because otherwise people will stop taking a look at warnings. And currently, when you compile Go code, warnings are very few, and almost all the time they are correct. So I would say static analysis is good. You can find many tools out there. I am not an expert in the field, but try to not overdo them and try to not push them too much down the stack. Like if there is someone that needs to go through the checks once when they submit a PR, good. But if those warnings are going to appear every time a programmer builds the tests, that is not good, because otherwise people will just start ignoring them. Let's see, there are no other live questions. So I guess I'm gonna go on with the saved questions. So someone asked questions about cookies. So there are two kinds of cookies that I can talk about. For example, there are cookies for the browser and cookies for eating, just, you know, actual cookies. Right, so when you deal with cookies in the browser, I think that is very complicated. So I guess I'm gonna go for the easiest part, which is the cooking one. To make cookies, I usually go for 1 part sugar, 2 parts butter, 3 parts flour, and then I add the flavoring like on the moment. My favorite flavorings are like a little bit of cinnamon, some raisins, and a splash of brandy. But you can use whatever you prefer, as long as the ratio 1, 2, 3, which is again 1 part sugar, 2 parts butter, 3 parts flour works, and you can add basically whatever you want. And then you just blend it together, not blending, but just mix it together, make small dollops, and bake it for, I think, 12 minutes in a 180 oven, something like that. For browser cookies, it's a little bit harder. Cookies are a big issue. Someone is writing, I think you got the sugar and flour inverted. No, 1 part sugar, 2 parts butter, 3 parts flour. I think is, I mean, this is how I make them, I guess. I'm gonna check later. Actually, I have my cookbook here. So bear with me for a moment. In the meantime, I can talk about cookies in the browser. Cookies are used for authentication, and I think that's a big mistake. I mean, now that the web platform is made that way, there isn't much we can do, but keeping state No, the recipe was correct. Keeping state in the browser was a big issue. Yeah, maybe I mispronounced it once, but 3 parts flour, 1 part sugar, 2 parts butter. So HTTP, which is the protocol that browsers use to communicate with the server, is stateless. So servers and applications don't know every time you issue a request if it's still you or if it's someone else. So at one point, cookies were added to the browser, and cookies are sent on every request, and this is sad, you issue to a website. And by every, I mean every request. Doesn't matter if the request comes from another site. For example, let's say you have bank.com, which is your bank, sets a cookie in your session, and it recognizes you through that cookie. And then if evil.com issues a request to bank.com, the cookie for bank.com is going to be added automatically to that request, which is useful sometimes, but dangerous most of the time. And this is a flaw that is being built into the web platform for the longest time. So there are some attributes that you can set to cookies which are useful. So for example, you can bind them to domains, to paths, you can make them secure, HTTP only, you can make them same site. And I guess that the most usable and secure approach you can have is to have them secure, HTTP only, and same site lax, which in some browsers is going to become the default in the future, the same site part. Secure means that the cookie will only be transmitted over a secure channel. Even if you set it on an insecure channel, which is weird because you can set a cookie and never see it back if you set it over HTTP. And then there is the HTTP only attribute that makes the cookie invisible from JavaScript. This is just to mitigate some XSS. It doesn't really work. So it's there just to make some exploits harder to write, but it's not really a strong security mechanism. While the same site lax is a trade-off. So if you know that your website will always only be accessed same site and your users will access your website from the home page every time, you can set same site strict. If you set same site lax, is easier because people can navigate to your site and still be authenticated. The difference is navigation. So if I click on a link on a website that leads me to another website, the cookies will be sent if they are lax and will not be sent if they are strict. For everything else, almost, lax and strict behave the same way. So if, in the example before, evil.com issues a request to bank.com via fetch or via form submission, for submission depends, but let's say fetch, the cookies will not be sent, regardless if they are same site lax or same site strict. So people writing that the same site attribute is changing that a bit. Yeah, it is. And especially the default. I know that Safari already kinda applied same site lax by default because they partitioned the browsers in a way so that when you visit a site, all requests are non-navigationals, do not send cookies. I think it was done for privacy, but it also got this nice security improvement, which, considering it is Safari, is I think a good step forward. Let's see if there are... Someone is writing, oh no, kinda. Interesting question. What is the most secure REST API authentication method? So by REST, I think we're talking about APIs that are requested by a page, and they're usually JSON, not necessarily, but usually JSON, in which you issue a request in the background while the user interacts with the page. So you don't perform a full navigation, but it just obtains data in the background or patches data in the background. Those APIs are So if you authenticate them with cookies, you have some issues. As I was saying before, for example, cross-site request forgery is one. If you authenticate them in other ways, for example, a secret token that is stored in your session storage for your page, and that JavaScript retrieves every time it needs to perform a request and attaches it somehow to the request. Now, let's say that you add a header, the authorization header. I think that's probably the best way to do it, because you can have a middleware that just checks authorization in the beginning, even without looking at the body of the request, and checks if the request is authorized, and then you have your business logic that deals with the rest. I think it's always better to have authorization and authentication in one place. And in this case, the authentication should be in the first possible place, and authorization should be in the last possible place. And I can get to that in a while. I think that the token that you put in the header should be something secure. And by that, there are many ways to obtain it. You can use JWT or JOT. You can use SAML. You can use just a token that the server generates when you log in, and it stores it in some sort of hot storage that is responsive, so you can retrieve it easily. Or you can have a signed token, so the server can, for example, emit the current time, your user, an expiration date, sign the entire thing, and send you this blob, and validate the signature on the receiving end. This is something like JOT, but smaller. I've seen mechanisms work like that. I think that today, the most secure one is still the random token. So you generate a one-time pad token, you send it to the user, and the user needs to attach that very same token to every request. This is an issue, because that means that your servers, all your servers, need to have a centralized storage for your cookies. Or in this case, not cookies, but they need to share the secret token. That is not always doable, and when that is not doable, I think something like JOT or a signed token works better. But there are some things that are tricky and easy to get wrong. For example, JWT allows you to have both encryption and signing, and I've seen a lot of people confusing those. So they encrypted the JOT, but they did not sign it, so anyone could forge it. And then there was some sort of like server-side code that was decrypting the JOT to validate it. Also, there was the problem with the non algorithm, because in the JWT JOT, you can specify in the header the algorithm that you're going to use for validation, and that was originally used for signing. And JWT supports none. And some libraries still allow you to validate with none, which means that there is no validation. People will just accept. If you write, I'm the admin, the server will accept the admin, and it will trust the client on the algorithm to use. Moreover, you could, for example, set a symmetric key algorithm while the key was generated with an asymmetric key algorithm. And that also created a lot of issues because the key that was used for validation was public. So there are many things that you can get wrong with JWT. I think my suggestion would be, if you want to use JWT for validation and emission, you can, but please fix the algorithm. Like, you go for one algorithm that you use to generate it on the server side, and when you receive a JOT, you have a first check. Does the JOT use the algorithm that I set? If not, decline. And then you call into the library that validates it. I think this is the only secure way nowadays to use JWTs. There is also the problem with invalidation, but we can talk about it in the crypto chapter of this series. I see a question, what's the most secure, okay, no, what? Was it difficult to get a job at Google in Zurich? Yes. As I said in the beginning, I'm not going to talk much about Google, but yes, because the interview is quite long and you need to wait for an opening in the security team in my case, and it was also hard for other reasons that are not part of Google. Like, I find moving very stressing, so in the beginning it was very harsh, especially considering that I left I left most of my friends in Italy, so that was harsh. Yeah, someone is pointing out that there is no HTTP-only flag for session and local storage. So when I was talking about not using cookies for authentication, but using something that stays in the local storage, that means that if someone exploits your JavaScript with an XSS, for example, they can access the token, send it to the attacker, and then the attacker can impersonate you. This is bad. And HTTP only tries to mitigate this with cookies, but again, if someone gets an XSS in your browser nowadays, and you're using a modern browser, they can install service worker for that page, and they can gain persistence in so many ways that the HTTP only flag is basically useless nowadays, I would say. Yeah, I think that, so once I saw that, so I used to be a penetration tester before I joined Google, and I saw a website that was setting the HTTP only flag, and I found a way to gain persistence with an XSS and just keep using the cookie. Even if I couldn't read it, I could still use it for anything that I wanted. And when the client found out about it, it was a very sad moment. It was like, I had to explain to them that that flag that they thought about when they were doing the security part was not that useful. So I don't think that using authorization headers is going to lower your security. The best authentication for gRPC? I have no idea. I have no clue. Honestly, I've used something like a gRPC inside Google. I've never used it outside. And inside Google, we use something for authentication that I cannot talk about. So sorry about that. I see. Okay. Who allowed this man a soundbar to make more awful jokes? So I don't have a soundbar. Actually, I wanted to add some sound effects to just make it more, fun, but I didn't have a soundbar. I'm currently casting from Windows because my personal computer has Windows because I only use my personal computer for gaming. And I looked for programs to add sounds to the live. None of them worked. It was like insane to try and make them work, and some of them were only demo. So I have this thing, which is Razer gamepad that I use for gaming. And today I wrote a program to make it behave like a soundbar, which was an intense 20 minutes of coding and made me sad because it was so much easier to write it from scratch rather than finding something that worked on the internet. I miss the Linux apt-get feel. I have a question about mass assignment, which was mentioned in conjunction with the Go Time episode 129. Okay. Have you personally come across instances of mass assignments in Go code? So, Bobs, I think I need you to expand on that. Like, what do you mean by mass assignment? Like assigning 4 variables in a single function call or something like that? Yeah, thanks, Ale. I will lower the volume on the soundbar. So while I wait for Jubobs to add information on that, I have a question on log management and actionable logs. Logging is hard. I think logging is one of the hardest parts of maintaining a software, because a lot of people will need to interact with logs, and logs are for humans. Like, writing codes for machines is hard, but not as hard as writing code for humans. And that's why I usually go for structured logs. Some logs that can be parsed in a structured format, something that is usually easy to grep or filter for, and something that allows you to have levels, like from debug to usually fatal, which is like debug, info, warning, error, fatal. And this kind of range is important. Moreover, the thing that you log should have like a root cause, a position in the code, and a message. I hate stack traces. Like logging with stack traces, like if you use structured logging and the stack trace is in a hidden by default field, fine. But if someone reading your textual logs needs to skip through all the stack traces, your logs are useless. Like seriously, if you have a plain text log, not unstructured, do not print stack traces because they're like impossible to parse through. Use structured logging, add as much information as you want, just keep a field for a simple message for humans to read and a position in the code that codes the log to be issued. Yeah, someone is complaining in the chat about the very readable Java stack traces. Yes, and Python, also Python. Also, if I recall correctly, Python and Java like use a different call. I don't remember which ones, but like two of the languages I interact with frequently use different notations in which the most recent call is in the top in one of them and is the bottom in the other one, and that is just driving me insane. So, not a big fan of stack traces. Ooh. I have a question on my recipe for baci di dama, which is a very nice kind of patisserie thing that we make in Italy. I think they're very complicated, but needlessly so, but I haven't found the time nor a way to simplify the recipe yet. This is a thing that I do a lot, like taking a recipe and trying to make it simpler without sacrificing too much of the taste. Like I hate when people say, oh, you are not supposed to do it like that because it's traditional, blah, blah, blah. I don't care. And this is a drill. I think my neighbor decided to assemble furniture today. Cool. So, for baci di dama, I use the same recipe as you can find in a popular Italian website, which is Giallo Zafferano. The only difference that I make is that I make them much bigger. Like, they tell you to make like a 1 gram cookie. That comes out too small and too crunchy, so I prefer to make them slightly bigger. Also, baci di dama are cookies, while instead like stuff like cantucci are biscuits, and those are quite longer, but I think simpler to make. So if you find the time to make something in-house and bake some patisserie things, I would suggest to go for biscuits, so stuff that is cooked twice, because it gives me much more satisfaction, and you can dip them in stuff and they absorb much better. So I see there is some activity. So it's not the soundboard, this is a real drill, and yeah, it's I did not make the drill sound. This is actually my neighbor. Yeah, I'm sorry about this. Yeah, Laura is writing. So Laura lives with me, and we noticed that since my neighbors moved in, they started hammering all the time. But seriously, all the time. It's been like 3 months of constant hammering, like every other night. And I thought, well, this is fine. I can still stream because the hammering usually doesn't take too long. And now they moved to drilling. I guess next step is... No, actually, I don't want to know what the next step is. And no spoilers, please. Oh yeah, in Switzerland, they're very rigid on the amount of noise you can make, like after a certain hour, but I think that hour is 10 p.m. and it's still not 10 p.m. here, so meh. I think they're still allowed 25 full minutes of noise, but I don't plan to stream that long. Yes, that's true. I can record this dreaming sound and use it on the soundbar next time. Right, that's a good idea, actually. So, let's see the other questions. Oh, I have a question on threat modeling. Threat modeling is something that everyone does, even if they don't know, every day. Like when you leave your house, every day, not in 2020, but when you leave your house, if you do, you do some threat analysis and some threat modeling. You decide first to leave your house from the door and not from the window, especially if you're in a high floor, because yes, it would get you to the ground level much quicker, but I think it would not be optimal to reach the ground that fast. And second, when you leave your door, you lock it. And you have security key or something like that, and that is not perfectly secure because someone can pick your lock probably, but is secure enough. So like picking that lock would take enough time for someone to notice that something is wrong or for you to come back. And this is basically what security is about, regardless if it is on the web or on software or on your house. When you build a website, you have to make sure of two things. First, that you don't go out from the window, and second, that you lock your doors in a secure enough way. There is no such thing as unhackable or secure software. There is just secure enough software, and software that didn't just jump from the window. I'm going to leave this metaphor behind me, and let's talk about the jumping from the window. Jumping from the window is stuff like you have a database which contains your users and all the personal information and all the data, and you leave it exposed to the internet because it's easier to manage access. And you might laugh, but like I think that MongoDB in the default setup used to have an open database exposed on the internet, and for the longest time many databases were exposed to the internet with users' information. I think also S3 buckets were exposed to the internet. So try not to jump from the window, and once you got that covered, you have to lock your door. Locking your door means making sure that you're using somewhat of a secure authentication algorithm, like allow your users to pick their passwords, but check if they're strong enough. Do not allow admin resources to anyone in your company. You always require like 2 people to approve for something to be accessed. The passwords that people use should also be backed up by second factor of authentication, especially if you're holding like private data. Like if your website allows people to like customize their avatar and that's it, and just download cute images, a password is enough. If it is a bank we're talking about, second factor or even third factor might be a good idea. And all the credentials that you store, always store them in an encrypted way. And by encrypted, I don't mean just crypt them so that you can decrypt them later, but use hashes, strong ones, like not MD5. Try to use stuff like bcrypt or scrypt or password-based key derivation function 2. I think that's the name of the algorithm. And once you do that, you're basically locking your door. You're trying to make sure that authentication is kind of taken care of. You should also use like secure frameworks, secure defaults. And once you do that, you basically lock your door. Someone can still climb to the top of your house, crash through the window and enter your house complex, find a spare key and get out of the door with your TV. But I think that's long enough to deter people from doing it. So I see that there are some comments. People are complaining that they came from security and they got food and they got fat. It's not my fault. I'm also getting fat in this year. I mean, we got time to cook and a lot of time to eat. It's hard to resist. I mean, it was easier to resist when yeast and flour was basically impossible to find in stores, but I think stores by now figure it out. So for the second wave, in Europe at least, it's gonna be hard to not put on weight. Especially because, as you have seen, I have very big glasses, which means that if I wear a mask, I don't see because they fog up. Favorite recipe? Wow. Huh. Someone is asking for my favorite recipe. So, it really depends because it's like, there are many things that make up for taste. More flavor. Like when I enjoy something, there are many components to it, like taste, aroma, and like nostalgia, because maybe that's a food that I had when I was a kid, and consistency, and then there is like color, the look of it. There are many things that make up for a good recipe. So if I had to pick one favorite recipe, my answer would be, I don't know. I really don't know. If you ask me for my favorite dessert, I can tell you that tiramisu and profiterole are pretty high up. Also, what are they drilling through? Are they looking for oil? So, sorry about the noise. So, tiramisu, profiterole, probably favorite desserts, I would say. For breakfast, I think that brioche bread with a little bit of Nutella on top is hard to beat. And for first course, I would say pasta with ragu. And or risotto. And for main dish, like something like second dish, pork ribs with some sides of like Brussels sprouts and mushrooms. I don't know. I like to eat different things. Even if I gave you my favorite dish recipe and you proposed it to me every single day, I would start to hate it. Okay, people are regretting. Oh wow, yeah. Laura pointed out that baci di Alassio is probably one of my favorite sweets. Yes, it is. But that one is like you eat one, you're full for like an hour, and you gain some weight that you're going to lose in like 17 months. Okay, I have positive news. I think my neighbors just got to oil. I think we're about to get invaded here. Sad joke, sorry. So, I think I ran out of questions. So, if there are any more questions in the chat, I'm gonna take them. Otherwise, I think I'm gonna call it a night. Yeah, that was a horrible, horrible joke. Sorry about that. But at least I didn't need to use the soundbar. That's the perk, because sounds were already provided by the background. Okay, I think I answered the questions. I think the technical test went fine. I guess the soundbar is too loud, so I will try to lower the volume. But yeah, I think we're good. Thanks everyone for joining. And you know they will stop. Yeah, I know the neighbor will stop as soon as the stream stops. I think they have my stream opened and they're waiting for it to finish so they can stop drilling the walls. Okay, thanks everyone. Good night or day, wherever you are, and see you next time for a lesson on XSSs and how to avoid them. Bye. How do I close these? Like these?